Hello guys, hopefully that you are actually doing this recording for the lessons that we have actually passed. Okay, so this is actually for the revision for the factors and multiples as well as integer. So by now you should have received the worksheet itself. So you try to do the worksheets and try to do, and this is just a revision for the Sec 1, the opening of the Sec 1 for schools. All right. So basically, when you look at the questions itself, right, it will cover index notation, it will cover square root, squares, and cubic numbers. At the same time, it also cover integers. Okay. So without further ado, let's if you please do not view the recording if you have not viewed the you have not done the papers. Okay. All right. But if you have, good. All right. So you can actually take a look at it. All right. And okay. Let's without further ado, let's start. Okay. All right. So let's take a look at the first question. The first question says, find the index notation of 1800. So 1800 itself, this is using prime factorization. Okay, so you divide by 2. Now you cannot divide by 9. Why can't you divide by 9? Because it's not a prime number. Okay, so when it's not a prime number, you cannot use it as prime factorization itself. So there you go, you divide on all the way until you reach 1. Okay, all right, so there you go, divide by 3, that will give me 15, divided by 3, that give me 5, and divide by 5, that give me 1. So in index notation itself, that will be 2 to the power of 3, multiplied by 3 to the power of 2, multiplied by 5 to the power of 2. I hope you got this question correct. Okay, all right, let's take a look at the second question. Okay, second question again, 2720. Again, you divide by 2. Okay, divide by 2 again, and divide by 2, divide by 2, and quite a bit of 2 inside here. Okay, and divide by 5, that should give me 2 to the power of 5, multiplied by 5, multiplied by 17. Okay, all right, so this itself is the index notation for 1008 and 2720. Let's move up. 1296. Okay, 1296, again, check the answer. Now if you have already done it and you got the answers correct, you can actually just look at the solution, slide the video forward. Okay, 324 2162 divided by 2, 1 divided by 3, 27, 39, 3, 3, 3, and 1. Okay, so the index notation is 2 to the power of 4 multiplied by 3 to the power of 4. Okay, all right, so how do I get the index notation? By looking at all the factors over here. Okay, all the factors is a multiplication of all the factors. Okay, let's take a look at the next one. 3600, you divide by 2. All right, and if I'm writing too fast, you can actually slow down the video. And the good thing about it is that you can actually just do it at your own pace. If you find that it's too slow, you can actually just forward the video. Okay, all right, so the index notation of 3600 is 2 to the power of 4 multiplied by 3 to the power of 2 multiplied by 5 to the power of 2. So you need to write. Now some students ask me whether if there is a need to write in order of numbers, smallest base to the largest base. Yes, you need to. All right, it's just for easy referencing. Okay, all right, okay, let's move up. Okay, without further ado, let's move up. Now, this next question is talking about HCF and LCM. How do you find HCF and LCM using prime factorization? Now, this is called method number 1. Now, in my class itself, we have method number 1 and method number 2. Number 2 is actually comparing base. Number 1 is using prime factorization. How do you do that? basically what you do is that you write it as if that you're doing prime factorized. Okay, so you divide by 2, that gives you 18, and 60, you divide by, so you see, hey, I can divide by 2 again. That should give me 9 and 30, and divide by 3 again, that should give me 3 and 10. And there you have it, 3 and 10. What is this called? This itself is your HCF, okay, highest common factor. And this gives you 2 to the power of 2 times 3. Okay, that should give me a number 12. Okay, and then you continue on, because once you continue on itself, you can just basically write this in index notation if you want. Okay, you continue on. Why do you need to continue on? Because you want to find the LCM. And you divide by 2 again, that should give me 1 and 5. Now, a lot of students tell me, can you divide by 10 or not? Cannot, because 10 is not a prime number. So, there you go. You will get LCM over here. 2 to the power of 3 multiplied by 3 to the power of 2 multiplied by 5. Okay? Alright? So, you have got H and LCM. Always remember, HCF comes first, and then you want to achieve to 1, 1. Let me just, okay, to find LCM. Okay, without further ado, let's take a look at question number 2. Divide by 2, divide by 2 again, divide by 2 again. Oh no, you can't divide by 2, divide by 3. Divide by 3 again. Divide by 2. Oh, sorry. Divide by 3 is already passed. So here is the HCF. You cannot divide anymore, right? That gives you the HCF. And there you go. You got HCF over here, 2 to the power of 2 times 3. Okay, if you want to write the index notation, by all means. If not, it's fine as well, right? Divide by 2 and divide by 13. Okay, so the LCM is actually equals to 2 to the power of 3 times 3 to the power of 2 times 13. Because you need to include everything inside here, including the HCF. Okay, all right. So this is what we covered yesterday. Again, I will not use the. I will not come out with the answer, because you can use calculator. Let's move on to the next one. The next one itself is actually 42 and 188. Okay, you divide by 2, 21 and 94. Then you may be stuck in this point where you say, hey, I cannot divide anymore. What should I do? Okay, true enough, you cannot divide anymore. So the HCF is basically 2. But you can continue writing. Alright, so this is can continue writing until you get 1, 1. So this is divided by 2. That gives me 147, and divide by 47 I think is I think it's a prime number if I'm not wrong. Okay, alright, so the answer is 3, 4, 5, 6. Okay, LCM is 2 to the power 2 times 3 times 7 times 47. Is that okay? Alright, so I hope that you got this correct. And the next one, again, do exactly the same thing. Divide by 2, 31 and 60. You can't divide anymore, so essentially you cannot do anything else. So your HCF over here will be 2. You divide by 2 again, divide by 2 again, divide by 5, divide by 3, and divide by 31, because 31 is a prime number. So the LCM for this, in this case, is 2 to the power of 3 times 5. Okay, not times 5, times 3 times 5 times 31. Okay, all right, so you have got all the HCF and LCM done in this using prime factorization. Okay, so let's move up. Okay, if you need the answer, just pause the video. Okay, now the next one will be actually what we call comparing base. Now if you cannot remember, 5 to the power of 4, this itself is called base. This itself is called power, or you like to call it index as well. Okay, all right. So what you're going to do is that you're going to align. The first step is to align all the base together. So you align all the base together, doing this. Okay. Now the second one is to fill out the blanks. What do you mean by fill out the blanks? Hang on, give me a minute. Let me just bring this a little bit closer to the other end. Okay. 2 times, times 3 times 5 to the power of 2. Okay. Then you realize, hey, there is a missing link in the 3. So you times 3 to the power of 0. And this is 1 times 7 to the power of 0. Okay, so this is what we fill in. Step number 1, align. Step number 2, fill in. Step number 3, very simple. HCF is to find the lower of the 2 power in one base. Example, this will be 2 to the power of 3, 3 to the power of 0, 5 to the power of 2, and 7 to the power of 0. Essentially, you don't need to write the power of 0. You can just erase them, and this becomes your HCF, highest common factor. Yeah, the LCM in this case, okay, now you can use calculator to find out the answer. All right, not an issue. Now is to find the higher of the 2 power. All right, the base, you compare the 2 bases and then the higher of the 2, the power. There you go. Here. Okay, all right. So this is actually to find out HCF, LCM using comparing base. Okay, second one. Same thing, do this, align them together. And then after you align them, make sure that you put in the fill in the blanks, and 11 is like 11 to the power 1 essentially. Okay, so HCF will be the lower of the 2 power, all right. So this itself, you can use calculator. Of course, I repeat again, there's no need for you to put 11 to the power 0, 13 to the power 0. So you can use and do this for your, to calculate it out. Okay, all right, let's move up to the next one. 2 to the power 6 times 7 to the power 3 times 11, 2 to the power 4 times 3 to the power 7 times 7. Again, this one you use HCF and LCM. Okay, all right. So here, put in the numbers, and there you go. 2 to the power of 4, 3 to the power 0, 7 to the power 1, 11 to the power 0. Okay, again, erase the 0 away. Okay, all right. Does it matter if you put 7 to the power 1? Doesn't matter. The 1 is still okay. All right, but people don't really write it by default. Okay, so there you go. You got the LCM and HCF of these 2 numbers. Okay, all right. All right, so let's move on to the next one. 2 to the power 4 times 5 times 7 times 11. Now, for those who are listening this recording for this, and you have already attended a lesson, I suggest that you don't look at your worksheet. Okay, all right, or rather the paper that you have written on. Okay, you redo this yourself. Okay, I say, oh, okay, I have already aligned them. what you're going to do is that you're going to put in the numbers. Alright, so HCF is 2 to the power of 4 times 3 to the power of 0 times 5 to the power of 0 times 7 times 11. Again, no need to put in the 0. And the next one will be LCM 2 to the power of 5, 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1 times 11 to the power of 2. Okay, right? So you can actually use a calculator to type it out. Okay, so I hope that you have get a good grasp of HCF and LCM for by prime factorization as well as comparing base. Okay. The next one, I want to draw your attention to what is the meaning of square roots. The meaning of square root means square root of 9 will give me 3, because 3 times 3 will give me 9, and 3 to the power of 2 square root will give me 3. What does this mean? It means that the power, when you see a square root, you divide the power by 2. Example, square root of 3 to the power of 10 gives me 3 to the power of 5. Okay, alright, so without further ado, let's see how we can do this using prime factorization. Right, of course you type calculator square root of 4225, you get some answers, but over here you need to use prime factorization to help you along. Okay, so what you do is you divide by 5, divide by 13, divide by 13. Okay, and you know that the index notation is 5 to the power of 2 times 13 to the power of 2, which gives me 5 times 13, 65. Okay, you can use your calculator to check the answer as well. Okay, same thing with the next one, 18496. Okay, give me a minute. Alright, divide by 2, divide by 2, divide by 2 again, divide by 2, divide by 2, divide by 2, divide by 17, and divide by 17. Okay, so the index notation is 2 to the power of 6 times 17 to the power of 2, which gives me 2 to the power of 3 times 17. Okay, alright, so 2 to the power of 3 times 17 is 136. Okay, so this is square root of this number. Let's move on to the next one. Now this is called cube root. The meaning of cube root means that you take the power and then you divide it by 3. So without further ado, let's try 3375. You divide by 3 first. Okay, hang on. 1125 divide by 3. 375 divided by 3. 125 divided by 5. 25 divided by 5. 5 divided by 5 and 1. Okay, so the index notation is 3 to the power of 3 times 5 to the power of 3, in which when it's cube rooted, you divide the power by 3. That should give me 3 times 5, 15. Okay, alright, so you got this. Alright, let's move on. Two nine 1,6 divided by 2. 458 divided by 2. 729 divided by 3. 243 divided by 3. 1 divided by 3, 27 divided by 3, 9 divided by 3, 3 divided by 3, and 1. So the index notation is to the power 3 times 3 to the power 6, and cube root, that give you 2 times 3 to the power 2, which gives me 18. Okay, all right. So you will be able to see that when it's cube rooted, you take the power divided by 3. Okay, let's move on. Now the next revision is this. All right, so I suggest that you pause the video if you are not you haven't done this, okay? And then during the class itself, normally I'll give some time to do, but I will just continue with the answer, but pause the video if you have not done it. Okay, so this is minus 5, this is 2, minus 9, minus 4, this is minus 2, this is minus 1, this is minus 6, this is minus 1, and this is minus 4. Okay, all right, so check the answer against mine to see that you have gotten it correctly. Okay, let's move. Oh, there's another one, minus 5. Okay, let's move on to the next one. Now always remember that when you see a plus, a minus and a minus, it will give me a plus. Again, pause the video if you have not done this yourself. Okay, so this minus 5 plus 3 gives me minus 2. 1 minus 5 plus 3 minus 2. You realize that plus and minus will give me a minus. Minus and minus will give me a plus, right? It's like some of you say, minus is more powerful. Okay, right? So 1 minus 4 is minus, 1 minus 5 is minus 4, plus 3 minus 2. Minus 3. Okay, all right. Next one, minus 1 minus 3 plus 4. Because this will give me a plus. Minus 4 plus 4, 0. Okay, the next question, 1. Again, 1 plus 1 plus 1 minus 1. 1 plus 1, 1 plus 1 plus 1 plus 1 minus 1, that should give me just 2 alone. Okay, all right, so you have got all this, check the answer, all right, to make sure that you get all correct. Okay, this one, you need to get all correct. Okay, all right, let's move on. Now this is called level 3. Level 3 has got bracket. Remember your Bodmer's rule itself. All right, next week when I see you, I'll be probably, the next lesson we'll do we would do a multiplication of negative numbers. Okay, so this is minus 1. Minus 4 plus 3. 4 plus 3 will give me 7. Okay, this is minus 9 plus 9 plus 9 plus 9. Okay, that should give me 18. Okay, that's question number 2. Now question number 3 itself, 7 plus 7 minus away, whatever is a bracket should be done first. Minus 14 plus 7. That should give me 7 alone. Okay, all right. Once we are done, we move up. And the last one, level 3.5, because these questions are a little bit, not really complicated, but just for you to try. Okay, all right, just remember, minus and minus give me a plus. Okay, check your answer again, pause the video if you have not done it at all. Okay, all right, so 3 plus 3 minus 6 plus 3, that gives me 3. Okay, the next one, 5 minus 5 times 0, answer 5 alone. Why 0? Because whatever that's done, whatever that's in the bracket, do first. Next one, minus 8 plus 8 plus 8 minus 8. That gives me 0 as well. Okay, all right. The next question, oh, this should be a multiplication. So minus 1 plus 3 times 0. and answer -1. Next question, -3 plus 2 plus 2 minus 2. That should give me 3 plus -3 plus 2 minus 1. -1 plus 2 minus 2 should give me 1 minus 2 minus 1. Okay, and the last one, this is 6 minus away 0 times 6. Where do you get 0 from? 6 minus 6 is 0. Okay, all right, and you know that this is a positive sign, so you don't need to write it in at all. Answer 6 minus 0, 6. Okay, all right, so that sums up the whole entire first lesson. But of course, with you doing it and checking the answer, it takes a little bit of time. But this is essentially the first topic of Sec 1, as well as a little bit of a second topic, which involves integer. Okay, so whatever it is, if you don't really understand, you can ask me in class.